In this lesson, we're going to look at some examples of using percentages in problems, so using them in calculations. A patient's fasting glucose level decreased from 140 milligrams per deciliter to 115 milligrams per deciliter. What percentage did it decrease? So this problem is not simply using the two values given in the problem because it's asking about the amount of decrease, not the relationship between the original and the final value. So we can still use the same equation relating to percentage, but we need to think about it a little bit differently. And so when we think about the part, because it's asking about the decrease, the part in our equation is going to be the amount of decrease that happens. The whole will be the original value. Because it started at 140 and we're decreasing from that value, the original value is going to be our whole amount. And that's going to be the case anytime we're looking at a decrease or an increase. The whole will always be the original amount because we're saying how did it change from this point. So we get our equation, percent equals part over a whole times 100. And this time, instead of just putting in a single value, we're actually going to have to do a calculation in the part because we said that's the amount of decrease. So 140 minus 115 milligrams per deciliter is the amount of decrease, divided by the original amount as our whole, so the 140 milligrams per deciliter. And then when we solve the problem, we get 17.9% decrease. So it's very important that you read the problem carefully and make sure you understand what's being asked. This example is a little bit more complicated, and so you have to read through the details carefully. A patient is receiving methadone, 40 milligrams per day in 2 doses. The dosage is dropped by 10% after 2 weeks. What is the new amount per dose? So notice that the amount they gave at the problem, the 40 milligrams, is per day, not per dose, but we're asked to find the new amount per dose. So like before, we start with our equation, the percent equals part over a whole times 100. We know that the decrease is 10%. We know that the original amount was our 40 milligrams per day, so we're actually solving for the part in this problem. I'm going to move up here, ran out of room, so 0.10 equals part over 40 milligrams per day after we divide it by 100. And what we find is that the part is equal to 4.0 milligrams per day. And we did that by multiplying 0.10 times 40. And this is the amount of decrease. This is not the amount per day, nor the amount per dose, but simply the amount that the dose is going to decrease by. So now we need to find the new milligrams per day. So we know the original amount was 40 milligrams per day. And we're going to take away 10% of that, which is 4 milligrams per day, and we end up with 36 milligrams per day. The total amount per day was spread over 2 doses, so we actually need to divide this by 2, and to get the new amount per dose, we're going to have 36 divided by 2, which gives us 18 milligrams. You could also solve this problem by figuring out the amount per dose, so 40 milligrams per day divided by 2, which would be 20, and then finding the 10% of that and subtracting it. You're still going to get to the same answer of 18 milligrams.